Hello, welcome to your lesson on speed, distance and acceleration. So very quickly, just go through the do now questions, just write the answers in your book or on your notebook, and pause the video and we'll go through the answers in a second. Okay, so what's the equation that's linked speed, distance and time? So we have speed equals distance divided by time. Okay. What is acceleration? Okay, it's the rate of change of velocity. Okay, so it's how quickly you can get quicker. Okay, how is acceleration calculated? Okay, so we have acceleration equals the change in velocity divided by the time for change. Okay, and in a second we'll look at how we can write that as an equation. Okay, so speed, distance and time. To calculate your speed, you must know the distance travelled and the time for your journey. Okay, so very simply put, we have speed equals distance divided by time, s equals d over t. All right, we can write that in the triangle if you wish. Okay, so we're going to have distance at the top and then speed times time. Okay, we should avoid using the triangle though, because we want to be able to calculate these things. You're given the equation in the exam paper on page 2. Okay, so all you just need to do is just cover up the bit you're looking for. Speed equals distance divided by time. Time equals distance over speed divided by speed, and distance equals speed times time. Okay, so speed is measured in meters per second. Okay, so it's how the distance is divided by time. Distance is measured in meters. Okay, and time is measured in seconds. Okay, and there's our rearranged equations also. All right. Again, we're looking at velocity here. So speed is a measure of how fast something is traveling. Okay, velocity is a measure of how fast something is traveling, but in a given direction. Okay, so velocity is dependent on the direction you're traveling. Okay, and here we've got displacement divided by time. So displacement is the distance moved in a straight line or a given direction from the starting point. All right, so if we look at this problem from BBC Bitesize, you walk all the way around the house in the diagram in 20 seconds. Okay, so you start this top right corner, you go around, okay, and you walk all the way around. Okay, so to calculate your speed, we need to know the total distance. So speed equals distance over time. Okay, distance equals 10 plus 10 plus 10 plus 10, which is 40 meters. Okay, and we're told the time is 20 seconds. Okay, so we're just going to have 40 divided by 20, which gives us 0.5 meters per second. Okay, so to find the velocity, we're going to use almost exactly the same equation, but it's displacement this time. Okay, so it's the distance moved in a straight line or a given direction from the starting point. So how far have we moved once we've walked all the way around the building? Well, we've gone 10 meters away, and then we've moved across 10 meters, and we've moved back up 10 meters, and then we've moved back to our starting point. So this time our displacement is 0. Okay, so V equals D, oh, sorry, no. Velocity equals displacement over time. Okay, but displacement equals 0 meters. Okay, so in that case, our velocity is going to be 0 divided by 20, which gives us 0 meters per second. Okay, because we've ended up at the same place, we haven't actually moved anywhere. Okay, we haven't moved ourselves away from our start point, therefore our displacement is 0. Okay, so it's very important that we recognize the difference between distance and displacement. Okay, distance is how far you travel, displacement is how far you travel in a straight line or a given direction from the starting point. Okay, in this case, we've ended up back at the starting point, therefore we have a displacement of 0. Okay, so look, we need to know about scalars and vectors. Okay, so scalar quantities have a magnitude. Okay, so they only have a size. All right, so things like length, area, volume, okay, speed, mass, okay, it doesn't have a direction, it's only a size. Okay, when we look at our vectors, they have a magnitude and a direction. So displacement, we know, it's the distance travelled in a given direction. Velocity is speed in a given direction. Acceleration is either positive or negative, okay, it's again in a different direction. Momentum, force, lift, drag, thrust, weight, okay, these are all types of forces. They all have a direction, and that direction is important, okay? So it's very important that you remember that a vector has a direction, and both scalars and vectors have a magnitude size, okay? So again we've got an equation. So this time we're looking at acceleration, okay? So this is the rate of change of velocity. All right, so the change in velocity is important, okay? So that gives us that part of our equation, the change in velocity. Okay, rate is regarding to time, as you know from your chemistry. Okay, so when we look at acceleration, it's measured in meters per second squared. Okay, so it's very important that you remember this is meters per second squared, because we have meters per second at the top. Yeah, we're going to have a value in meters per second here with a direction, and then we're dividing it by time, which is in seconds, so we get meters per second squared. Okay, so our initial velocity u, final velocity v. To work out the change, okay, what we're left with, sometimes this is a negative number, okay, and that will give us a negative acceleration, meaning that the object is slowing down, okay. When it's a positive, it means it is speeding up, okay. So okay. Okay, and obviously slowing down is deceleration, speeding up is acceleration. Okay, so there's our basics for speed, distance, and acceleration. If there are any questions, obviously ask your teacher, send them a message, or speak to them in person, and good luck with your questions. Thank you very much.